Hello everyone, this is Miss G once again, and today we will be talking about free body diagrams. So, free body diagram is a very interesting tool in physics, which is basically a graphic tool, and that represents all the forces which are acting on a specific object. And we represent the forces with the help of arrows indicating the directions of the forces. And the length of the arrows also indicate the magnitude of the forces, how big the forces are and along which directions the forces are acting. And this also helps us analyze different types of forces, their identification, and in also using Newton's laws of motion to find out different variables linked with these kind of diagrams like mass, acceleration, forces, etc. So as you can see on the picture, we have two diagrams. One, there is a box on the left hand side which is indicating the object, and there is an applied force which is working towards the right. So this is the force which is acting towards the right, and this is normally called the applied force, which is trying to push this object towards the right. And then we see a small little force over here, which is the force of friction. This is working towards the other direction. And as you all know, that friction always opposes the movement of any object. So that is the reason the force of friction is always acting opposite to the directions of the applied force. Then we have the weight of the object, which is acting downward and which is given by mass of the object times gravitational acceleration. And we also have a normal force acting in the upward direction, balancing the weight of the object. And this normal force always acts upward from the surface which is holding the object. So this helps us in analyzing in detail about everything the object is experiencing, all kinds of forces the object is experiencing. Now on the right hand side, you can see there is an inclined plane and we have another box on this. Now just because it's an inclined plane, so it is inclined at a certain angle. In this picture, the angle is 30 degree. Now you can see the weight of the object will be always acting downwards, so we are going to put it down. The arrow should be always pointing downward. Now we have one component of the force which is acting along the ramp downward. Now this component is basically the weight of the objects, the component of the weight of the object to be more precise. So this is the weight, this is the actual weight. If we resolve it into two components, so now if this angle is theta, which is 30 degree in this case, so this angle would be 90 minus 30, which is 60 degree. So as you all can understand, this would be 30. So therefore, if W is acting downward, this component of W would be W cosine 30 degree. And there will be another component of W, which is the weight of the object, that's W sine 30 degree. And W sine 30 degree is pulling the object downward. Now, just because there is a downward force acting on this ramp, on the object, there has to be an upward force which is going to resist it. And most of the time, this force is the force of friction. So this is friction in this case. All right, and then you can see there is another force acting from the surface, which is the normal force. And as you all know, the definition of a normal force always acts at 90 degree to the surface. So this is, as a whole, the free body diagram of any object. Now, free body diagram is very interesting because it helps us frame equations and solving problems related to it. And it makes things very clear right in front of our eyes about the forces that these objects are experiencing in different situations. And the picture becomes very clear. So now we are going to apply this concept of free body diagram and we are going to solve this problem. This is one of the problems from College Board. It says that a cart rolls along a track that is inclined at an angle of 37 degree to the horizontal as shown. At the moment shown, there are three forces exerted on the cart: a downward force of magnitude 50 Newton, a drag force of magnitude 20 Newton, and a normal force from the track of magnitude 40 Newton, as shown in the free body diagram. The magnitude of the vector sum of the forces on the cart is most nearly, and there are some options given to you. All right. So as you know that we represent any object in the free body diagram with the help of a dot or with a box. So we have been already given this free body diagram for this cart. So it's showing that there is a force of 40 Newton acting on it. So 40 Newton is basically the normal force. And then we have 50 Newton, which is the weight of the object, which is acting downward. And we have 20 Newton as the drag force. Now, we need to find out the component of the weight which is actually acting perpendicular to this ramp. So the component of the weight is basically going to be 50 cosine 37 degree. And why is it so? Because as you can see, this is a right angle triangle. We have this angle given, that is 37 degrees. So this would be 90 minus 37. So naturally, this angle has to be 37 degree. So then this component of the force is going to be 50 cosine 37, and there is another component which is acting downward along the ramp, and that's going to be 50 sine 37. So let's find out the values of 50 cosine and 50 sine 37. So remember, your calculator has to be in the degree mode as you are trying to find out the values. Cosine 37 is 0.798. Multiply it with 50 and you get 39.93. So 39.93 Newton. And then we have sine 37 degree is 0.601. Multiply it with 50, you get 30.09 Newton. That is going to be along the direction of the ramp. So now let's draw another diagram which is going to just show all the forces that we have found. So there is one which is 40 Newton, which was already given to us. And this force 39.93 is counterbalancing it. We have this force which is acting down the ramp, that is 30.09. And we have the drag force which is acting opposite to it, and this is 20 Newton. So now we have to simplify it even more. We have to subtract the forces which are acting opposite to each other. And then 40 minus 39.93 would be 0.07. So 0.07 is acting in the upward direction. And we have 30.09 and 20 now. So 30.09 minus 20 gives us 10.09. So 10.09 Newton is acting in the downward direction. Now, since these two forces are at 90 degrees to each other, we are finding the resultant of it. So for any resultant, remember, the resultant normally acts along this direction. We need to apply the Pythagorean theorem. So R should be equal to square root of 0.07 square plus 10.09 square. And if we try to find out 0.07 square plus 10.09 square, we get 101.813, 101.813, and then we need to take the square root of it. So and that is giving us 10.09 Newton. So our answer should be B. Thank you for watching, and please subscribe to my channel, Crack the Physics. Please post your comment and feedback Any questions that you have, please post it and I'll try my best to put the answers in. Thank you once again. Bye bye.